Hi friends, welcome to EROTECH Solutions. Let's see the last feature from microcontroller, serial communication. Okay, so in previous sessions we discussed about timers, counters, interrupts, and now we are looking for serial communication. So before proceeding the serial communication feature from microcontroller, so you should understand what is the difference between IO port and serial port and what type of communication your microcontroller is supporting. And you should know the minimum terminology about the communication. Okay, so our main motto is always for communication means exchanging data between two devices. So I am trying to exchange the information between two devices. So either I am trying to send my data from device 1 to device 2, or I am trying to receive data from device 2 to device 1. Okay, so that you need to use some standard terminology here: transmitters, receivers. Okay, and also the other few words in communication you should be most very keen on: protocols and baud rate. So these are the regular words you may heard in communication. Okay, so our final motto is always sending data or receiving data. But in all communications you cannot do both transmission and as well as reception, but again you have to follow some methods, or you have to follow some rules and regulations to share the data between two devices. Okay, so what are the basic methods in communication? So like if you take it simplex method, so which means so only one way of sending data, either transmission or reception is possible in simplex. Okay, so like it is, the other name of simplex method is one-way communication between two devices. And again here you are trying to use transmitter, receiver, not devices in communication. And again those are two electronic devices, that's it. Okay, so whenever you are trying to share the data, if you are doing only one way, it is comes under simplex method. And the second method is half duplex. So here the two things are possible, both transmitter and reception is possible, but at a time you can do only one thing. You cannot go for transmission as well as reception at the same time. So that is your half duplex method. And coming to full duplex, the full duplex is very clear. You can do transmission and you can do reception at a time between two transmitters and receivers. So this will, you can find it for simplex method. The no walkie-talkie is the best example for simplex method. So for radio communication is comes under simplex method, whereas half duplex best example is walkie-talkies. Once the other person is talking, you need to keep it in receive mode. The other person is in receive mode, you can talk. So that is your half duplex. So, and whereas full duplex is your telecommunication. So whatever the mobiles you are using, so these are all comes under your full duplex. So this is how, this is a simple example, like, or this is the simple methods in communication you have to share your data between two devices. But again there are two different communications which are supported by these methods, which are serial and parallel. Whereas if you are sending bit by bit between two devices, like bit by bit means you need to allow to send or receive information in form of again zeros and ones, but it will happen bit by bit between transmitter and receiver. So that is comes under serial communication. Whereas parallel means you can easily notice that, so there are group of lines between transmitter and receiver, so which means the two devices connected with more number of physical lines in the case of parallel, which means you are trying to send some group of bits at a time between transmitter and receiver, either transmission or reception, but not bit by bit. Here you are sending some group of bits in the case of parallel communication. So again, based on application, people have different methods and different communications, either serial communication or parallel communication. But now the most popular serial communications are like USB, Okay, so and whereas parallel communication, which is TCP/IP. Okay, so these two are the major industry level two communications you have, which is one is USB and TCP/IP for internet. Okay, so this is how you can do your serial and parallel. But what about protocols? So every protocols has its own some set of rules and regulations. If you are trying to pass your data between two devices, you need to follow some rules and regulations clearly. So what are the rules and regulations followed by such protocols? So you should follow those rules and regulations compulsory to share the data between two devices. Either it is a parallel or serial, you need to learn about protocols whenever you are entering into communications. Like, what are the known serial communication protocols in market, which are UART or UART, I2C, SPI, CAN, USB. So these are the most popular protocols in market if you are trying to do applications. Even you have so many other protocols in communications, but these are some standard used protocols towards applications. And coming to parallel side, so you will find TCP/IP is the best communication protocol to send or receive the data between two devices using parallel communication. Okay, so whereas serial communication, which is preferable between two devices, which is very clear, because nowadays every product which is coming up with most communication choices, like you can communicate through VGA, you can communicate through HDMI, you can communicate through LAN port, you can communicate through USB. So like every product which is coming up with different set of communication access for us. Okay, so whenever you are trying to connect two devices, you need to follow any one of this communication port. So without this protocol support, your device is not possible to communicate with the external world. Okay, so every communication which has to support one inbuilt protocol compulsory, and based on that protocol only you are trying to exchange data between two devices. But how to notice that the device is following which protocol? Like coming to UART and UART, from any microcontroller, if you want to say the controller which is supporting UART, from the device you can find these two physical lines, RxD and TxD from the device. Whereas if you want to notice the device which will support I2C communication, you can easily notice that SD and SCL lines from the device, which is serial data line and serial clock line. And coming to SPI, the device maybe supports MISO, MOSI physical pins. And coming to CAN, you may find CAN-H and CAN-L lines. And for USB, D+ and D-. So these are the standard physical pins related to protocols. Every protocol, you want to say the devices have on-chip protocol, UART, on-chip protocol, I2C. So from pin diagram, you have to notice these physical pins. Okay, so that is the one blind mark for us. So what are the protocols supported by so and so microcontroller? Okay, and coming to TCP/IP, which is coming up with trace lines. So this is the one important point. You can remember this for protocol support. What protocol which is supported by the microcontroller? Okay, so this is a simple information behind the serial communication or parallel communication and their methods. And protocol is very clear, which is some set of rules and regulations, and microcontrollers are supporting different protocols based on the manufacturer. If you are working with different manufacturers, the controllers maybe support different set of protocols, and if you have more protocol support from the controller, you can do more applications. Like if you have I2C and SPI support, you can communicate with EEPROM chips and RTC chip and ADCs, serial ADCs rather than parallel ADCs. Okay, you can deal with I2C and SPI support. And if the device is supporting on-chip USB support for us, it is easy to access anything, like any physical device you can access with the help of USB communication. Okay, so that is the main mode of supporting on-chip protocol from the microcontrollers. Now finally your 8051 microcontroller, which is supporting serial communication with UART protocol. So from basic 8051 I am not finding all the protocols on chip, which is supported by only the basic protocol, which is UART, so that you will find the RxD and TXT pins across pin number 10 and pin number 11 from the controller. So this is supported by your microcontroller. Okay, so finally your 8051 is supporting serial communication with the UART protocol. Okay, so now whenever you are trying to use the serial communication feature from microcontroller, again for every feature what I said, you should learn the SFR registers. Like serial communication related SFR registers are SCON and SBUF. So these two registers you need to remember for serial communication. And the first register SCON, the SCON register, which is helping us to enable the serial communication by using this standard register in different modes. Okay, the name itself, serial control register. The first two bits from SCON register, SM0 and SM1. So these two are mode selection bits, and based on the logics of these two bits you can decide the mode of serial communication. Okay, so for this, based on these two bits you may have 4 combinations, 00, 01, 10, 11, and 00 combination is mode 0 here. So whenever you are choosing mode 0 in serial communication, which is supporting shift register with fixed baud rate. So what is meant by shift register for serial communication mode? So what you said, so which is supported this UART protocol on chip, but from microcontroller UART protocol means which is allowing to share the data with start bit and data and stop bit. So for every 1 byte of data, which allows to add 2 additional bits, start and stop. Whereas if you are choosing serial communication in mode 0, so this is allowed by doing shift register method. This means always the data transmission from LSB to MSB. So this will change from protocol to protocol. This is also one of the difference between protocols, like whether you are sending or receiving data from LSB to MSB or MSB to LSB. For UART protocol, the rule is very clear. You are allowing to share data from LSB to MSB. But in this case, in the case of mode 0, you need to keep the bit whatever you are looking to transmit, keep it in LSB position. Now, so shift register means for 8 bits of data transmission, you need to do this shift operation on your regular data. Now 0-1 combination is mode 1. So this mode doesn't need any shift operation. You can keep 8-bit data here between start and stop with variable baud rate. So variable baud rate means you can change the baud rate according to your external device baud rates. Okay, your microcontroller is capable of working with different baud rates. Like you can change your baud rates according to requirement just by choosing mode 1. Okay, and 10 is mode 2, and in the case of mode 2 you can place 9-bit data. Like rather than keeping 8-bit data in between start and stop, you can place 9-bit data also in the case of mode 2. And this mode allows fixed baud rate. It won't allow to change baud rate of controller. And 1-1 combination is mode 3, and this mode 9-bit data with variable baud rate. So these are the differences in case of modes of serial communication. Okay, but the most selected mode is mode 1 for us serial communication operations. And the next bit is unused from SCON register, and REN means receive enable bit. So this receive enable bit, this will make us to keep receive operations with external device to the microcontroller. If you are looking to receive any data from external device to controller, make it REN bit logic is 1. And you don't want any data from external device, make it 0, logic 0, it disables your receiving operations. So no data received from external device to controller by making RE and bit logic 0. And TB8 and RB8, so these two bits for noticing the error of stop bit while doing transmission and reception. So according to this data frame of UART protocol, the last bit is always stop bit, and this stop bit you are finding any error with while doing transmission, the TB8 is becoming 1 automatically while doing transmission. So otherwise the default state of TB8 logic is 0, and when it is going to 1, whenever it is finding stop bit error while doing transmission. And what about RB8? So RB8, it is logic 0 by default, and this will become 1 whenever you are finding stop bit error by doing reception process. Okay, so these two bits are noticing that any error with any stop bit error while doing transmission, TB8 becomes 1. While doing reception, your stop bit error have any logical error, your RB8 becomes 1. And what about TI and RI bits? So these two bits are transmit interrupt and receive interrupt. Transmit interrupt default state is 0, and this is becoming 1 whenever 1 byte data successfully transmitted from controller to external device. And RI is becoming 1 whenever you received any data from external device to controller. So these two bits are helping us to know successful communication or successful transmission between controller to external device and successful 1 byte data received from external device to microcontroller. So finally your SCON register bits are helping us to select the mode and monitoring stop bit logic and successful transmission or reception by using TI RI bits. So this is your SCON register individual bits. Now you will see this. So what are the steps you need to follow for programming? Like the first step is set SCON register value. So according to this SCON register, so what is the mode or what is the logics you need to decide? 0, 1, and you are looking to receive any data from controller to any external device to controller, make it 1, and TB8 RB8 default state is 0, and their initial status of TI and RI should be 0. So according to this, the SCON value is 0x50. So 0101 is hexadecimal 5 and 4 zeros is 0. The second step from serial communication, select timer 1 in mode 2. So timer 1 mode 2. So how to choose timer 1 in mode 2? By using tmod register, and tmod register equivalent value is 0x20. And the third step is set the baud rate by using formula th1 is equal to -x. So how to calculate x value here? So the x value which is calculated, which is based on the oscillator frequency of microcontroller. So mostly whenever you are looking for serial communication, the working frequency is 11.059 MHz, and this is given to this frequency is divided with a on-chip divider 12, and this frequency is forwarded to on-chip UART block, which is having a fixed divider 32, and then this is your programmable divider which will decide the frequency or baud rate of microcontroller. If you divide this 11.059 with the 12, you will get some 0.988 megahertz, and if you divide this thing with 32, you will get 28,800 hertz, and this is after this programmable dividend. Whatever the frequency you are getting, that will be the baud rate. So 28,800 is the exact frequency I am getting after UART block, and you are looking for 28,800 baud rate, make sure X value is 1, and you want to make it some low baud rate, like the other controllers or other modules are working with different baud rates, but the standard baud rate of external devices, which is 9600 mostly. But how to make this 28,800 as 9600? Just by using this programmable dividend. I am just making 28,800 divided by X, which is equated with 9600. So from this, X value is 28,800 divided by 9600. So I'll get 3. So this X value is 3. Whenever I am fixing X value 3 here, the baud rate of microcontroller is 9600. What minus represents here? This is the 2's complement of your input number. Whenever you are making the 2's complement for -3, you will get FDH. Okay, so this is just 1's complement plus 1. So for 3, 1's complement means 0 0 1 1, and this will become 1 1 0 0 with all 1's. The MSB part is F, and adding with 1, FC plus 1 is FD. Okay, so once you are fixing the X value here, this will decide the baud rate of controller. And fourth step is the buffer register you need to use for storing your data. SBUF is equal to some character. Whatever you are trying to transmit, make sure the character, it should be loaded with SBUF. And wait for TI status 1. So I am staying here until TI becoming 1. So this TI, which will remain 0, whenever your data successfully transmitted, the TI becomes 1. Then only it understood that 1 byte of data transmitted successfully. So that is the importance of TI monitoring here. And you have the further communication or further transferring data with microcontroller, make sure TI is 0 and repeat your process with SBUF. And finally stop your timer. And here you need to start timer after setting baud rate. Then load your data with SBUF and wait for TI and make it TI clear and repeat the process. And you don't have any data transmission and it is completed, make sure TR1 equals to 0. So these are the steps you need to follow for serial communication. So this is how the total features of microcontroller is completed, and in the next session we will go for applications. Thanks for watching.